Okay, we're going to cover a few definitions that are basic to our discussion of forces in motion. First off, we're going to explain the word force. What exactly is a force? And the book will tell you that it is simply a push or a pull. And to get a little bit more specific, it is when an object interacts with another, when one object places a pressure or an exertion on another object to make it change its motion. So, pushing a box, pulling on a cart, a tug of war rope, trying to pull the other end, and also something called the force of gravity that is always on us and pulling us down to the center of the earth. So any sort of push or pull trying to change the direction or change the motion of another object. Hopefully that's pretty clear to you. I think it's pretty simple concept to grasp. The next one is exactly what a Newton would be. Let's use a different color. A Newton. And a Newton is basically our measure of force. Our measure of force. And just like we measure length or distance in kilometers, or we measure mass in kilograms, we measure force in newtons. And a Newton, symbolized by an N, is basically the amount of force needed to move something that has a mass of 1 kilogram, make that object move at an acceleration of 1 meter per second per second. So in other words, a Newton, to abbreviate, is mass times acceleration. Okay, and thinking about it, it's pretty intuitive to understand how this works. If we wanted to move something that was something, I don't know, very heavy, 100 kilograms, and we were going to move that 1 meter per second, it's going to require a force of 100 newtons. 100 kilograms times 1 meter per second. And in order to move this object at this rate, it would require 100 newtons of force. If we wanted to take that same heavy object and move it faster, that's going to require even more force. So if we wanted to move it at an acceleration of 5 meters per second, it would require 500 newtons of force. And then on the other hand, if we had something very small, let's say only 5 kilograms of mass, and we were going to move that 5 meters per second, even though we're trying to move an object the same amount of acceleration at the same rate, because it's much smaller, it's not going to require as much force, and this example would only require 25 newtons of force. So the larger mass something has, the faster you want to move it, will require more and more force, and that's measured in newtons. And then finally, we have the idea of balanced and unbalanced forces. So if let's say we took a box and I don't know, I was pushing it and trying it to make it go in this direction, and I was pushing at a rate of 5 newtons. Okay, and I know I said pushing, and I drew the arrow this way, but that's just kind of the way it's done. It's the line, the arrow shows the direction of my push or pull, and then someone else is pushing or pulling in this direction at another equal rate of 5 newtons. Then those two forces will equal out. There will be no motion because it will cancel each other out, and this would be considered a balanced force. So we can remember balanced force as having no movement All right, and what we did here was actually something called a net force, and that's like the resultant velocities we may have looked at in another video. Okay, this is a net force, and since the 5 newtons and the 5 newtons, the net force would equal 0 newtons. All right, because again, they cancel each other out. And then if we take a different example, let's say we take the same box, and instead of 5 newtons of force on this side, we'll call that 10 newtons. And then over here, we'll call that 5 newtons. And if you notice, I drew the arrow for the 10 newtons longer, and that's something they do in physics. This is called a vector. All right, so the longer the vector, it represents the greater amount of force, and so this is a shorter vector, and this is an example of a smaller amount of force. And so the 10 newtons is greater than the 5 newtons, and so the net force would equal 5 newtons to the left. Okay, or maybe I should say 5 newtons left, something like that. Okay, and that would be our net force. And of course, since there is a net force, this box would be moving. And that would be an unbalanced force. Okay, and so an unbalanced force would have some sort of movement connected to it. Okay, 7 minutes, kind of long than my usual videos, but 4 important ideas to remember, but basically simple concepts, so I hope you got it.